Hello, tech enthusiasts, and welcome to another episode of Daily AI Brief, the podcast where we deep dive into the latest developments in artificial intelligence. Today, we're exploring breakthroughs that could redefine the landscape of AI research and implementation across various industries. From data generation technologies and reinforcement learning optimizations to the exciting realms of business intelligence migration and neurotechnology, there's a lot to uncover. Stay tuned as we embark on this insightful journey into the cutting-edge world of AI. In a groundbreaking move, Meta has introduced Autodata, an innovative framework that transforms the way training data is generated. Traditionally, creating high-quality training datasets is a manual, tedious process fraught with inefficiencies and human errors. Autodata aims to change this by leveraging AI agents to autonomously produce and refine datasets, functioning much like an autonomous data scientist. The four-agent system. Autodata employs a collaborative system of four specialized agents: challenger, weak answerer, strong answerer, and validator. Each agent plays a critical role in iteratively enhancing data quality through a systematic and cyclic process. Challenger agent. This agent is responsible for identifying gaps in the training data. By recognizing these deficiencies, it sets the stage for targeted refinement. Weak answerer. Once the gaps are identified, the weak answerer generates preliminary responses. Although these responses may not be perfect, they serve as a foundation for further improvement. Strong answerer. The strong answerer takes the initial inputs from the weak answerer and refines them. Through this enhancement, the data becomes more robust and representative of varied scenarios. Finally, the validator assesses the quality and relevance of the generated data, ensuring that each iteration enhances the overall dataset integrity. These agents operate in a continual feedback loop, with each playing a distinct yet interconnected role in building upon the other's work. This iterative loop is designed to continuously refine and improve the dataset, pushing toward optimal quality. Efficiency and technical details. Currently, specific performance metrics have not been publicly detailed. However, Autodata promises to drastically reduce the data generation time from weeks to potentially mere days, potentially accelerating the deployment of AI models significantly. This kind of efficiency is crucial in fast-paced environments where time to market is vital. While the framework's effectiveness in representing diverse operational scenarios remains to be fully validated, initial signs are promising. Rigorous testing is underway to ensure adaptability across different scenarios and applications. Practical applications and ethical concerns. For developers and tech enthusiasts interested in exploring this groundbreaking framework, Meta has made it accessible via their official Facebook research.github.io, blogs Autodata, UTM source OpenAI. Here, users can experiment with various training setups and review comprehensive documentation on Meta's AI initiatives. However, the deployment of Autodata does not come without concerns. Meta's approach potentially involves using sensitive employee data, like mouse movements and keystrokes, for model training. This raises significant privacy and ethical issues that could spark debate regarding data usage and employee consent. Conclusion. The potential implications of Autodata are vast. If widely adopted, it could revolutionize data generation within the AI industry by dramatically enhancing efficiency and quality. However, it also necessitates a delicate balance between innovation and ethics, especially concerning privacy. This framework may become a defining standard, setting new benchmarks for AI model training efficiency and data quality. Let's shift gears to NVIDIA's recent advancements in reinforcement learning with their integration of speculative decoding in the NeMo RL framework. For those involved in training large-scale models, rollout generation has traditionally been a bottleneck. NVIDIA's approach not only addresses this issue, but amplifies the efficiency of model training. Through speculative decoding, NVIDIA reports a speedup of 1.5x to 1.8x for 8 billion parameter models, with projections of up to 2.5x on the scale of 235 billion parameters. This is achieved by integrating a versatile VLM backend, enabling multiple token generations per processing pass, thus streamlining autoregressive tasks without altering crucial optimization trajectories. Such acceleration is impressive, as it reduces training times and potentially cuts costs significantly. The reduction in rollout time reported with frameworks like Spec RL attests to NVIDIA's leading position in optimizing reinforcement learning. The Spec RL framework, noted for reducing rollout time by 2 to 3x, and SRT's 2.08x speedup during rollout, complement NVIDIA's speculative decoding, enhancing overall performance. However, the effectiveness of speculative decoding across different model architectures and its long-term stability remain open questions. Generalizing to other tasks and models is another aspect yet to be thoroughly vetted. While promising, this technique's adaptation to varied reinforcement learning challenges requires careful evaluation. Developers are encouraged to explore NVIDIA's documentation on NeMo RL for speculative decoding guidelines and perhaps test this approach in their own workflows to harness these improvements. With the right tools and understanding, the application of this technique can be straightforward, involving steps such as reading the documentation, accessing the research paper, and implementing the technology in controlled tests. NVIDIA's advancement underscores a critical shift. Faster rollouts could lead to speedier research cycles and broader applications of reinforcement learning in real-world scenarios. In practical use cases, such efficiency could revolutionize deployments in sectors requiring rapid decision-making, from autonomous systems to complex data analysis tasks. Ultimately, this breakthrough may set new standards in the research and development of RL models, inviting competition and innovation in acceleration techniques. By improving efficiency, these advancements could make cutting-edge reinforcement learning more accessible to smaller organizations, democratizing sophisticated AI capabilities. AWS has launched a groundbreaking service, AWS Transform, that automates the migration of business intelligence (BI) workloads to Amazon QuickSight. Traditionally, migrating BI systems from platforms like Tableau and Power BI to new environments was a manual, cumbersome process that could take months. AWS Transform changes this paradigm by drastically reducing migration timelines to mere days, offering businesses significant enhancements in cloud analytics capabilities. At the heart of AWS Transform are AI-powered migration agents tailored specifically for commonly used BI tools such as Tableau and Power BI. These agents facilitate the automated transition by analyzing and converting existing BI dashboards, thereby shifting a historically manual task to an automated process. The architecture leverages AI to ensure streamlined conversions while maintaining the integrity and functionality of original data insights. In terms of numbers, AWS officials have stated that Transform has processed over 1.8 billion lines of code in recent months. This achievement translates to a reported savings of more than 1.09 million hours of manual labor, effectively cutting down the workload equivalent to 483 years for a single developer. When compared to tools like Wavical Data Solutions' Easy Convert BI, which promises up to 90% faster migration, AWS's offering sets a new speed benchmark in the industry. However, users must consider certain trade-offs and limitations. The efficacy of these migration agents can vary depending on the complexity and customization of existing BI dashboards. Additionally, there is a potential risk of vendor lock-in, as enterprises may become increasingly reliant on AWS services. Compatibility issues might also arise, especially with dashboards that are heavily customized or use outdated technology. From a practical standpoint, getting started with AWS Transform involves several steps. Users can access setup guides available on AWS's official blog, review technical documentation to understand prerequisites, or undertake a test migration of a sample dashboard from Tableau or Power BI to Amazon QuickSight. These resources are designed to ensure a smooth transition and provide users with the necessary information to leverage this automated solution effectively. The emergence of AWS Transform is a reflection of the broader industry trend toward automated and AI-driven processes in enterprise computing. By enabling faster BI migrations, AWS is not only enhancing operational efficiency, but also allowing organizations quicker access to AI-driven insights, potentially reshaping competitive dynamics in the BI service sphere. As businesses continue to prioritize data agility, AWS Transform positions itself as a pivotal tool, offering streamlined data management and analytics, while reinforcing AWS's stature in the ever-evolving cloud service landscape. Now let's delve into the Lambda hermes-agent-reasoning-traces dataset, a new tool for exploring agent-based conversation models. This dataset is a boon for researchers aiming to dissect and enhance AI agents' reasoning processes through detailed analyses of tool calling actions in dialogue scenarios. Released in early 2026, it provides meticulously structured data, especially useful for understanding and improving reasoning capacities in AI systems. The repository includes configurations such as Kimi K2.5, comprising 7,646 samples, and GLM 5.1 with 7,055 samples. Each sample features multi-turn dialogues enriched with detailed reasoning blocks, denoted as think sections, which are instrumental in dissecting how agents perform step-by-step reasoning, leading to decisions in tool use within conversations. Available under the Apache 2.0 license, this dataset is not only easily accessible, but also modifiable, allowing researchers to share improvements. Its release in Parquet format ensures seamless integration with prevalent machine learning frameworks, encouraging the integration of these reasoning traces into existing AI models. From the technical perspective, the dataset structure includes system messages, human interactions, and tool definitions. These components allow comprehensive parsing and analysis using tools like Python's pandas for data manipulation and visualization software to depict multi-turn dialogue interactions. Through advanced visualizations, researchers can uncover hidden patterns and insights into AI reasoning processes. For example, diagrams can illustrate the decision paths and tool call sequences followed by an AI during a multi-turn interaction, showing how these agents derive solutions over extended conversations. However, it's important to note the dataset's specificity might restrict its generalizability across broader AI applications. While it shines in tasks like customer support automation, where complex tool use is frequent, it might not entirely fit other domains without adaptation. To get started, you can directly access the dataset on Hugging Face, where it's hosted, and begin experimenting with parsing and analyzing agent traces. Leverage the dataset to create visual diagrams that explore AI interactions, potentially leading to breakthroughs in designing more intuitive AI systems. By opening new avenues to investigate AI behavior and decision-making, the Lambda hermes-agent-reasoning-traces dataset could pave the way for significant innovations in developing more intelligent and responsive AI agents capable of handling increasingly complex tasks and interacting seamlessly in varied conversational contexts. In neurotechnology, a recent study has unveiled a sophisticated end-to-end pipeline using NeuralSet to decode linguistic features from magnetoencephalography (MEC) signals. The aim? To better understand language processing in the brain, moving a step closer to seamless human-computer interaction. MEG technology offers superior temporal resolution, capturing brain activity in milliseconds, which is crucial for understanding rapid language processing. However, this precision comes at a cost: extensive noise and inter-individual variability. Decoding linguistic content from MEG signals has been a notable hurdle due to these complexities. The introduction of NeuralSet, an advanced neural framework, addresses these challenges by applying deep learning techniques specifically fine-tuned for noisy neural data. The study evaluated 723 participants across 3 languages, encompassing a dataset of approximately 5 million words. This large sample size underscores the neural decoder's capacity to handle vast linguistic diversity, revealing insights into how the brain processes different phonetic and semantic structures. By focusing on end-to-end learning, the study capitalizes on neural networks' ability to autonomously develop feature hierarchies crucial for language decoding, bypassing the need for manual feature engineering traditionally required in signal processing. Central to this approach are deep learning architectures, potentially incorporating recurrent neural networks or transformers. These models are adept at handling sequential data, capturing temporal dependencies that are pivotal in linguistic processing. Despite the lack of explicit architectural details, the pipeline's ability to decode words not present in the training set suggests robust feature extraction and pattern recognition capabilities. Data preprocessing is another critical component, involving filtering and denoising techniques to enhance signal quality. The model performance reportedly improves with dataset size, demonstrating a direct correlation between training data volume and decoding accuracy, which increased by a notable margin as more data was integrated. This highlights the importance of large, varied datasets for training effective neural decoders. Implications of this research are vast, potentially leading to advanced brain-computer interfaces tailored for communication aids. Such interfaces could enable individuals with speech impairments to interact with their environment through thought alone. For researchers and practitioners interested in exploring these advancements, replicating study methods with available MEG datasets offers an opportunity to test NeuralSet's applicability in various settings and languages. What a whirlwind of innovation! From transforming data generation and reinforcement learning to streamlining BI migrations and decoding the brain, today's breakthroughs promise to reshape AI landscapes far and wide. As these technologies evolve, staying informed and engaged will be crucial. Thank you for joining us on Daily AI Brief. Be sure to subscribe and tune in tomorrow for more insights into the fast-paced world of AI.